In section 2.3, we look at how the particles that make up atoms are organized, or what is known as atomic structure. So in modern atomic theory, we consider that the atom is comprised of three subatomic particles. These are called neutrons, protons, and electrons. And each particle has its own symbol. For the proton, it is a lowercase p with a superscript plus. For the neutron, it is a lowercase n with a superscript 0. And for the electron, it's a lowercase e with a superscript minus sign. These particles are very small, having masses between 10 to the minus 31 kilograms and 10 to the minus 27 kilograms. You can see that the neutrons and protons in an atom are about the same mass, with the mass of the neutron being a tiny little bit bigger. The electron is much smaller in mass than either the neutron or the proton. Often we will work in relative mass units where we assign a mass of 1 to a proton, and this shows nicely that the neutron and the proton have about the same mass, and the electron is very, very small in comparison to protons and neutrons. Protons have an electrical charge of +1, which is why we include the plus sign in their symbol. Neutrons have no electrical charge, which we indicate with a 0 in their symbol. And electrons have a -1 electrical charge, which we indicate with a minus sign in their symbol. It's important to recognize that particles with opposite charge attract one another, and for this reason, protons and electrons stick to each other or attract each other. Protons and neutrons are found together in what we call the nucleus of the atom. And so for this reason, protons and neutrons are sometimes referred to as nucleons. So in the very center of the atom, we have a bundle of protons and neutrons. The nucleus, of course, will be positively charged because it's made of protons that have a positive charge and neutrons that have no electrical charge. While the nucleus is very small, it contains almost all of the matter in an atom, greater than 99.9%, because the neutrons and the protons are much heavier than the electrons. The electrons are found at great distance from the nucleus, kind of orbiting the nucleus like planets around an atom. So for this reason, sometimes this model is referred to as the planetary model of the atom. It was Ernest Rutherford, who was a New Zealand/British/Canadian scientist, who was first able to predict the size of the atom and the size of its nucleus. And what Ernest Rutherford determined was that the nucleus occupies only 1/100,000th the total volume of the atom. What this really means, which is quite surprising, that most of all atoms, or most of all matter, is empty space. And what we mean by that is that the atom is composed of a tiny nucleus with electrons at great distance from that nucleus, and then most of the volume of the atom is the empty space between the nucleus and where the electrons are. Now, how this got figured out was by something that Ernest Rutherford's graduate students did called the Geiger-Marsden experiment. So what Geiger and Marsden did is that they took a radiation source, which was the element radium, discovered by Marie Curie, and radium is known to emit positively charged particles known as alpha particles. They fired these particles at a gold foil, and they chose gold because gold can be hammered into a foil that is just 1 to 3 atoms thick. So you can get very, very thin pieces of gold. So any alpha particle that passes through this gold foil is only going to hit a couple of atoms. Okay, and what did they observe? Well, what they did was they put a screen around their gold foil that glowed when an alpha particle hit it. And they saw that most of the alpha particles went through as though nothing was there, but a few of them got deflected because they were hitting something very hard and heavy, and then some of them even got deflected to very wide angles, and occasionally one of the alpha particles would actually get reflected or deflected back behind the gold foil. So how Rutherford interpreted this data was that as most of the alpha particles went through as though nothing was there, then atoms are mostly empty space. So that's why we put our electrons on the outside of the atom with our positive nucleus in the middle there. And so most of these guys go straight through as though nothing's there because nothing is there. However, every now and then one of our positively charged alpha particles will pass near the nucleus, at which point it is repelled, and so that guy will get deflected. And then every now and then an alpha particle will come in and it'll score a direct hit on the nucleus, and it'll get bounced back behind the screen. Now that's pretty rare because the nucleus is so tiny, and that's why there were so few that bounced all the way back behind the gold foil. Okay, so that's how we arrive at the planetary model of the atom. Okay, so this concludes the section on atomic structure, and we are now ready to look a little bit closer at what is going on in the nuclei of atoms.